Hi, tonight we're going to go over lesson 4.8. We're going to be talking about prime and composite numbers. Prime numbers have only two factors, 1 and itself. Composite numbers have many factors.
I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 2, 3, 5, 7, 11. Woo! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 13, 17, 19, 23, 29. Yeah! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 31, 37, 41, 43, 47. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 53, 59, 61, 67, 71. Hey, I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 73, 79, 83, 89, 97. Yeah, representing prime 1 to 100. Let's go. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Yeah, prime numbers. Prime numbers.
All right, let's take a look at our first number. We're going to figure out, is that number prime or composite, and then we're going to figure out if it's composite, the prime factorization of that number. And I'll show you what that means in a second. I have the number 30. I'm going to make a factor tree here, and I'm going to figure out what times what is 30. So I think in my head, well, I know 3 times 10 is 30. So I'm going to put 3 at the end of one branch and 10 at the end of the other. Now I'm going to look down to my 3 branch. What times what is 3? The only thing that I get to 3 is 1 times 3, so 3 is a prime number. This is the start of my prime factorization. I'm trying to find all the prime numbers that multiply together make 30. 10 is not a prime number. 10 is a composite because I can multiply 2 times 5. Let's take a look at 2. 2 is a prime number. The only thing I multiply is 1 times 2. 5 is also prime. 1 times 5 is the only way I can get to 5. So my prime factorization is 3 times 2 times 5. I would get to 30. Let's see if it was true. 3 times 2 is 6. 6 times 5 is 30. So there's my prime factorization. And I know because I have more than 1 and 30 down here that 30 is a composite number. Now I'm going to show you, what if you thought right away, I didn't think of 3 times 10, I thought of 5 times 6. Let's see if we get the same exact numbers. I'm going to erase this quickly. I already know that 30 is a composite number, so I'm going to leave that at the top. I know 5 times 6 is 30. 5 is a prime number. The only way to get to it is 1 times 5. 6, I can multiply 2 times 3. 2 is a prime number, and 3 is a prime number. My prime factorization is 5 times 2 times 3. The same exact numbers, just in a different order that we got with our other prime factorization. 5 times 2 is 10. 10 times 3 is 30. Let's take a look at another number. We'll see if it's prime or composite, and also the prime factorization.
Okay, 27. I'm going to start out by making my tree. I'm going to think, now what would go into 27? Thinking of my divisibility chart, 2 won't go into it. 2 plus 7 is 9, so 3 would go into it. 3 times what? 9. Okay, now I'm going to look at 3. 3 is a prime number. 1 times 3 are its only factors. 9, I can break 9 up into 3 times 3. 3, I have another 3. Again, they're both prime. Let's see if that works out. 3 times 3 is 9, times 3 is 27. How many factors are there? There's 3, so we know that, well, there's more than one in itself, so we know that 27 is a composite. Oops. Oh.
That's all right, Mrs. Moyer. We know what you mean. Let's move on.
Okay.
All right.
Next one.
Let's look at 24. 24, if I break it apart, 4 times 6 is 24. That's the first one I thought of in my head. You might have thought of something else. If I break 4 apart, 2 times 2. If I break 6 apart, 2 times 3. 2 is a prime number. This is my prime factorization, so I'm trying to find prime numbers. 2 is a prime number. 2 is a prime number. And 3 is a prime number. So my prime factorization is 2 times 2 times 2 times 3. Because I have all of those numbers down there, I know that this number is composite.
Okay, 63. Okay, I'm going to think of two numbers multiplied together that would equal 63. Start with my tree. Let me think. 7 times 9. I'm going to look at number 7. Are there any numbers that will go into 7 besides 7 and itself? No, there's not. So 7 is a prime number. How about 9? Can we break 9 up anymore? We can. We can break it into a 3 times 3. Okay, how about the 3's? 3's are prime. 1 times 3, only factors. So I'm going to write down my factorization equation. 7 times 3 times 3 multiplied together equals 63. Because I have these factors, I also know that 63 is a composite number also. Okay.
51. I have to think back to my divisibility rules. What times what is 51? It's not an even number. I can't add those together and divide it by 3. It doesn't end in a 5 or a 0. None of the divisibility rules work. The only way to get to 51 is 1 times 51. So my prime factorization is just 1 times 51, and because I only have 1 times 51, this makes it a prime number. Let's take out your notebooks, and we're going to add a couple notes. Mrs. Lamore is going to read them for you. As she reads them, make sure that you copy them down.
Okay, prime, meaning only factors are 1 and itself. Composite numbers, they have many factors or more than 2. Okay, first example, I want you to create your own factorization tree. So we're going to use number 21. Oops, let's try that. Let's see, 21. I know that 3, try that color. 3 times 7 is 21. I know 3 is a prime number because 1 times 3 are its only factors. And 7, I also know that's prime. 1 times 7 equals 7. So my prime factorization is 3 times 7. Now, I know that this is a composite number because it has more than 1 in itself as factors. Okay.
All right, let's take a look at our last example. 23. What times what equals 23? I cannot think of anything except for 1 times 23. 1 is prime. Of course, 23 is prime. My prime factorization is only 1 times 23, making 23 a prime number.
Now, can I just add something?
You
Sometimes, and sometimes this helps me, a lot of times if the first digit is an odd number, chances are that that number is going to be prime, if that helps to recognize a prime number. Not always, but sometimes.
Perfect.
I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 2, 3, 5, 7, 11. Woo! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 13, 17, 19, 23, 29. Yeah! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 31, 37, 41, 43, 47. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 53, 59, 61, 67, 71. Hey, I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 73, 79, 83, 89, 97. Yeah, representing prime 1 to 100. Let's go. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Yeah, yeah, prime numbers, prime numbers.